So in this video, I need to talk to you effectively about the true nature of a derivative. I've said in a lot of lessons, in a lot of ways, and in a lot of places, that the derivative is the slope of a function. And that's totally true, but the derivative is so much more than that. To be more accurate, a derivative is really about a rate of change of one quantity with respect to another. And I need to tie these things together because it is slope, but really it's about the rate of change of one quantity with respect to another one. So to sort of show you that and to show you the connection between that and slope, I want to look a little bit more closely at what slope is. And so I would ask you to think about what slope is. And my bet is that if I ask you, so what is slope, your gut response is probably something like, it's rise over run. And I'm going to say, yeah, okay, all right, that's what we picked up in algebra. Sure, slope is rise of a run. If I asked you to dig a little bit deeper, you might have had a teacher at some point that said that slope is sort of about steepness. Because it is, and I think that gives us a little bit more intuition. We have this sense that, if the slope is 3, it means you've got a really steep kind of thing. If you were trying to climb that mountain, you would want climbing gear. On the other hand, if it's a shallow slope, that's not so big a deal. And these are both, two different ways of thinking about slope. But I just told you that the derivative is slope and the derivative is also rate of change. So I kind of want to focus on this one, but I want to make it better, right? I want to look at this thing and sort of think like, what this is really saying is it's saying that the slope is the change in y compared to the change in x, right? So for instance, if we say that a function has a slope of 1/3, what does that mean in terms of rate of change? Right? Well, what it says is it basically says that y is changing by 1 when x is changing by 3. So this slope, it almost gives us an exchange rate. It gives you this sense that, at the instant that the slope is 1/3, it means that every time x changes by 3, y will change by 1. Now, if that slope stays constant, then you just have a line. And in the case of that line, you've got y changing by 1, x changing by 3. Y changing by 1, x changing by 3. Y changing by 1, x changing by 3. In the case of more complicated functions, like cubic functions or something, we have the slope changing as we go along. And every time x moves by a little bit, the ratio of the change changes. So at this point, what I've effectively said to you is I've said, hey everybody, the derivative gives us slope. And that's true, but that's only true because all of the functions that we've worked with so far have been y as a function of x. Right? One of my variables is y, one of my variables is x, and so when I look at a change, I end up looking at the change in y over the change in x, and that change gives me slope. But it should kind of make us wonder, what if I had a function that wasn't with y and x? What if I had a function that had different quantities? What if y stood for something different and x stood for something different? What would that derivative mean? Would that thing still be slope? Even if it was slope, would that derivative have some other meaning? And they totally do. The reason calculus shows up everywhere in the world and in academia and in studies is that anytime you have a function, anytime you have something changing with respect to something else, we can look at a derivative to model the way that change works. So I'm going to try and give you a little bit of a taste for this in an example that I hope will make some sense, right? So suppose that we had a function that gave some companies profit as a function of the number of products that they sold. So we would effectively have a function that said, hey everybody, our profit is some function of the number of things that we sold, right? My question is, what would the derivative be, both notationally and in terms, I'm sorry, I say it here, what would the derivative be notationally, and what would that derivative mean? What are those things about? So first of all, notationally, right? Well, remember, when we have y equals f of x, our derivative looks like dy dx. It's the change in y divided by the change in x. So in this case over here, when I'm looking at profit as a function of the number of things sold, notationally that derivative would be dp dn. Right? Now what would it mean? This thing would mean the change in profit compared to the change in the number of things sold. So it's basically how much more profit you get for each thing that you sell. And for those of you that are taking economics, like, I hope you've gotten this far in the course at this point to recognize, like, wow, that's actually a really useful thing. If we actually had a profit function, if I could actually look at the change in profit per how many things I sell, I could totally make decisions about whether I want to continue producing more things or if I don't want to. Now, there are lots of other places that the derivative gets used, and we're going to talk through some of those, but there's one in particular that's going to come up in the next video. With that said, if some things didn't make sense in this video, I really hope that you wrote down some questions or you put some stars on the side so that I can talk to you about them tomorrow.